All right, everyone, we are back, and we are going to resolve these forces into a resultant x and y resultant vector. So we're going to find a single resultant f, which will just be, again, basically f of, it's going to be the sum of all the f of x, sum of all the f of y's, which will be in x here times I vector plus f resultant in y, j component. So the way that I'm going to do this is I'm actually going to set this up in Mathematica. Mathematica is a simple tool. It's just a calculator, effectively. And we're just going to define some values in here. You can obviously do this, and we're going to actually set up the problem first by hand. But I like to use Mathematica in order to calculate the values, make sure I'm not making any simple math mistakes, and just because it's one of the programming tools that we use. And as engineers, we should use programming tools to kind of simplify the math for us. So you can download this with your basically Humboldt.edu account, but let's go ahead and break this down. So if I'm looking at the sum of the forces in the x, I'm going to be looking at force 1 magnitude times, because again, I want the x component, so it's going to be cosine of, I'm going to call it a cosine of 32 degrees, and then it's going to be, I'm also going to take the x component of this, which is in the minus direction, so then it's going to be minus f2 cosine of 13 degrees. And then finally, it'll also be, in this direction, it'll be plus f3 cosine of 27 degrees. And then for the y direction, it'll be f1 sine of 32, 32 degrees, plus, because this will also go in the positive direction, plus f2 sine of 13 degrees. But this will go in the minus direction, so that's going to be minus f3 sine of 27 degrees. So if I want to find those values, I'm just going to go ahead and I'm going to say, first, I'm going to make some definitions. F1 is equal to 150. It's just a calculator. F2 is equal to 50. F3 equals 160. And I'm going to say theta 1 is equal to 32. And I'm going to put degree here to make sure we're in degree mode. Theta 2 is going to be in 13 degree. And theta 3 is going to be equal to 27 degree. This is just putting it degree mode, just like in your calculator. And I'm going to say that f sub x, or frx is equal to f1 times cosine of theta 1. And actually, I'm going to go here. I'm going to do this plus, actually, minus f2 times cosine of theta 2 plus f3 times cosine of theta 3. So that's my, and I'm going to do backslash n to bring this here. So that's my resultant vector in the x. Makes sense because I have these. It's a good, check, right? Like these large magnitudes that are projected on x versus that single one here. And for y, I'm just going to change everything here from sine. This is the nice part about having a code too. Sine, f1, f2, and then minus f3. And there we go. That's our vector, or resultant vector. So we've done it. Amazing. Fantastic. So let's do one more. We can do the same thing here for this problem. Except, excuse me, we need to, actually, we'll do it in the next video. So we'll do another example problem to now use basically the sum of the force must be equal to 0. Actually, excuse me, not sum of the force must be equal to 0. Actually, we will use that to solve our next problem. So we'll see you then in the next video example.